Welcome back to another Taproot podcast. This week's topic is the history of root cause analysis. Now, looking at this, we could really go back a long ways if we want to think about where did root cause analysis come from? What's the history of different techniques?
Well, the longest I've got, Alex, is going back to 450 BC.
So I think we're going to have to go back, look at that history, how it's changed over time, and what that effect has really been on industry. So what's the oldest you had on your records?
Well, Socrates, Plato, and Aristotle between 450 BC and 300 BC really came up with a philosophical approach to cause and effect. And you can think of that as the start of root cause analysis, although I wouldn't call what they were doing root cause analysis. But the philosophy starts then in the Western world. I don't know about Asian cultures and when their first root cause analysis.
We'll have to go look at the Sumerians and see if they have it on the stone tablets.
We don't know about that, with the little chinky things they put in mud.
So the Greeks were looking at how do we understand the fundamental realities of being. They're looking at what is truth. And that led them to cause and effect.
Cause and effect. If you've seen a cause produce an effect, in the future, when you see that effect, you can assume that cause was the cause.
Now, we move further in the timeline then. We start to get into, let's say, the Enlightenment era, people understanding science and innovation. What's next in kind of our timeline of an understanding?
Well, David Hume, another philosopher, then goes back and criticizes the work of Socrates, Plato, and Aristotle and says, no. You can't assume that if you've seen an effect be caused by a cause, that today that same cause is producing the same effect. Because there could be more than one cause that could produce that effect or other changes that it could have occurred. So you can't make that assumption that just because something causes this with this effect, that all the time when I see that effect, it's caused by that cause.
So they go back, we have kind of the initial, you have a cause and effect. Now we say, well, there can be multiple causes of a single effect.
What he says is just a shortcoming of the whole philosophy. This was still a philosophical discussion in the 1700s.
Now, where did it turn? What was kind of the major event that made it turn from, we'll say, philosophical to getting more related to something? What's kind of the next in the timeline?
Hold on, there's still one more to go. Somewhere between the middle 1700s and the late 1800s, supposedly by what I've looked up, somebody started using the term root cause. I can't find a definite place. This was the first place we used. I found somebody published in some medical journal something about root cause, but it isn't perfectly, this is the first time it was used. So sometime somebody invented the term root cause, sometime back in antiquity, 1700s to 1800s, and therefore somebody had the idea of there was a root cause to a problem. And of course now we think sometime beyond that we went to, there could be multiple causation and multiple root causes for a single problem.
So the term gets coined somewhere 17th to 18th century.
No, 1700s to 1800s.
1700s.
18th
to 19th
century, 19th century.
18th century to 19th century. And following that is really the industrialization.
Industrial revolution occurs.
And with that comes what? War.
World Wars. World War I and World War II.
So the modern, I would say the modern, we won't say fixation on quality, but the modern start of the quality production system really comes out of in the U.S. and Europe and other Asian countries that were in the process of really a truly industrialized war, being World War II.
I don't know it might have gotten the ideas started off then. I think most of the tools and techniques came out of the late 40s and early 50s, or even up to the early 60s. And so that you might say that the war, there were problems people recognized in the war of manufacturing large numbers of things that they could improve their manufacturing quality. And I don't even know when they started calling it manufacturing quality.
Yeah. So in my timeline that I saw, looking at kind of that, setting that stage of 1930s going into 1940s, the first name that I kind of saw come up as in often ways the father of modern quality systems came out of Bell Telephone, and it was Walter Shewart. And he was recognized for basically really pushing control charting and the fundamentals of kind of the PDCA cycle. So PDCA being plan, do,
he was
check,
definitely
act.
Control charting. I might think of Deming more as the...
Well, so Deming and him both knew each other. They didn't write papers together, but they were both aware of each other's writings at the time. And Deming was working at the time for the U.S. government. So he was in, I think, the Census Bureau before the war. And so they had this big connection, the two of them. And when the war began, Deming went into the War Office, and he actually was getting the U.S. government to take a class that was put on by Walter. And that kind of connection was in relation to supply issues. So during the war, we were ramping up this production, and you would have ammunition problems, you'd have quality defects of things, and that in wartime, if your ammo's bad, what happens? Clicks the gun, you don't shoot the guy that's trying to kill you.
Interestingly enough, it was also the birthplace, more or less, of human factors. When they started crashing more planes on the U.S. side of the Atlantic and the Pacific during training, killing more pilots during training than were getting shot down on the other side by the enemy. And you think of it that way, it's like, oh, this is bad. How can we be losing more planes in training than we're losing in combat? Of course, we were trying to push a large number of pilots through in a short period of time, but human factors became a big part of that. And so the whole human factors discipline started end of World War II-ish, 50s and 60s.
So there's kind of this, we'll say, in the end of the World War II, you have this burst of manufacturing, this burst of industry, certainly in the U.S., but also rebuilding in other countries. And you have these guys that have this expertise in, we'll say, quality and statistics. Really, statistics is a lot of the mathematicians and I think both of those guys were physicists.
Who? Mathematicians.
Mathematicians, yeah.
Yep.
So they both had this mathematics, and you see that kind of start spreading into certain areas. Now, Deming, you saw more sharing over in Japan and some of those. And the U.S., you saw what was really coming through in U.S. companies for automotive and other things. What was kind of your timeline in the 50s? What were some of those iconic things in that time period, 40s and 50s?
Okay, so World War II, they invented failure modes and effects. And in the early 50s and early 50s, also 5 Whys, I think, was created in the early 50s. Although I saw one source that said it was created in the 30s, but I couldn't find that anyplace else. And so I think it was more the 50s.
So I couldn't find a definitive person that said this is the person that made FMEAs. I couldn't find a name.
U.S.
to it.
government is
Exactly.
what it said.
So
U.S. military.
What I saw was that it came out of, they were looking at these manufacturing defects, and they wanted to work with the suppliers to say what were the causes of these, and that became kind of a standard in the military, was to do these FMEAs.
There probably was a mil-spec written for it.
Probably. Then you kind of tie into the 5 Whys. Now, where did the 5 Whys come from?
What's his name? Taiichi Ono.
So
and what's his name?
And
the Toyota.
Sakichi Toyota.
Yeah.
So you have these these two guys in Toyota with the five whys, and to them, the purpose of the five whys was really to understand cause and effect. That if you asked why,
well, it was based on cause and effect.
Yeah.
Whether they understood the philosophy it was based on or not, if you go back and look, it's the five whys are getting you a cause and effect chain.
Yeah.
That's five deep.
So their philosophy was if we ask why enough, we will get down to the source of a problem. Now, again, we think back from our modern lens on this. We see asking why to a single source. What does that tie back to? All the way in the 1700s when they're saying no, that's already a problem with this. It's not one. There's not a single cause. But
well, multiple causation. You're
yeah,
sort
there's
of violating
multiple
that.
causes.
Of course, nowadays people will tell you, oh, you can ask five. Five isn't a magic number, and you can have multiple why chains, so you can have multiple causation. But that wasn't true at the start of it was five whys.
This is five. But there was at the same time period in Japan, you also had Ishikawa, who was...
Fishbones?
He's a fishbone. Ishikawa's thought was...
I got early 60s down for fishbone diagrams.
Yeah.
So it's a little bit later.
Yeah, I have it as between the 50s and the 80s. He started the stuff in the 50s,
I got early
but it was
60s
really...
that I saw. But
yeah, really didn't get coined as Ishikawa till the 80s.
And also, fault trees and Kepner-Trago was early 60s.
Yeah. So this time period, as he's looking at it, he's saying it's not single cause. There's different... And it's coined right now as kind of 6M. There's the 6Ms that are in there, which is manpower, machine, method,
Oh, this is your
material.
bones.
Yeah, your bones.
But your bones don't have to have standard names.
Well, the 6M.
Okay,
was
get all six of them in there.
So manpower, machine, method, material, Mother Nature, and measurement. So that was original 6.
You think that's original?
Well, it was in Japanese, mind you, so it's not exactly that.
I've seen so many different kinds of fishbone diagrams.
The additions, because now it's 8 M's, the additions is management and maintenance. Those are the two additional ones I've seen lately. The idea is you get some categories and you look down those for cause. So you almost take your little 6 branches and you do a 5 why for each one.
Well,
and you might have something you might
probably
not.
5. It's more like 3.
It might be 5.
Because your fish gets really squirrely if you get out 5.
So Ishikawa is pushing the idea that we're looking at there's quality tools that you need. And so he's got the fishbone. He thought that was one of the 7 quality pillars. He also believed in check sheets, Paretos, scatter plots, histograms, control charts, and flow charts. So he had this principle of saying, okay, there are foundational tools everyone in quality needs to analyze a system and look for defects.
See, but I think you're going down the quality line as the history of root cause analysis.
Yeah.
And I don't necessarily think the quality line is the history of root cause analysis.
I think that's probably true. I think there's definitely, because in that time period, you have this quality path that follows what Lean will talk about, what later Six Sigma and Lean all go into in kind of the 90s. And those trace their roots to this Japanese movement. But then...
Well, it really was an American movement because it was Shewart that started all this.
Yeah. So it traces down that line. But at the same time in the 60s as that's happening, you were saying these other methods were going on.
Well, that people were looking at analytical ways and systematic ways to look at safety and improve safety, or to improve management decisions in general. And so you've got something like Kepner-Trago that comes along that's really a management decision-making tool that can also be used, although not obviously how, for finding root causes. And so there's management system development and there's safety development on the safety side of things. And what you're going to find is a lot of these things that you're saying are quality tools start being adopted on the other side too. People start asking things like 5 whys, or you mentioned in there a flow chart. People start looking at a sequence of events for accidents or incidents. And they aren't really ready for root cause analysis yet, but they've got things like fault trees that they're developing that start saying, well, this out here, that's a necessary condition for this to have happened. And so that's getting pretty close to a root cause. And it's also being used in things like equipment reliability and equipment stuff, which you could say is quality, right? So it's all sort of getting stirred together. And you're up to the early 60s, and then along comes the 70s, and Ludwig Benner, who was at the NTSB, decides they have to do a better job of understanding what happened and comes up with a technique called multilinear event sequencing to lay out, I'll call it a flow chart, but he would say I'm not correct by saying that, of what happened. And that then becomes a part of events and causal factors charting, or events and causal factors charting. Maybe I'll call it a spin-off. It becomes a spin-off of multilinear event sequencing in the Department of Energy. And the Department of Energy puts together this thing called the System Safety Development Center. This is in the early 70s now we've gotten to. And the System Safety Development Center puts out tools, lots of different tools, some of which you hear today: barrier analysis, change analysis, events and causal factors charting, and the Mort tree as tools you can use for root cause analysis, mainly the Mort tree for root cause analysis. And those become sort of a first off used in the Department of Energy, which is mainly nuclear weapons production. So a pretty good risk there if you screw up. So you don't want to have that happen.
So we sort of see this, and I won't say co-development timeline, but you kind of see from coming out of World War II, you see suppliers and manufacturing going down a route that they were basically, because there were these mil specs that said, hey, you've got to meet these quality standards, that kind of leads a quality route down in the supplier.
You have to meet these standards. We wouldn't call them quality standards.
Yes,
yet.
They were mil specs and NATO specs, and they didn't get called standards until probably the 80s. But you've got these standards that are being established.
80s and 90s.
Yeah, 80s and 90s.
We went crazy with ISO.
Yeah. So we get these standards start coming in from the civilian side. You have in the military side and nuclear side, which is really in tandem together with the civilian nuclear side. You start getting these tools that get developed, and industrial safety is also evolving over this, because we start to see regulatory agencies being involved in incidents. So there's generation of new.
Well, in the 70s, for instance, OSHA was formed.
Yep.
EPA was formed. We didn't have a national regulator for safety or in the environment before then. It's all during the Nixon administration that those regulatory bodies were formed. I'm not sure when MSHA came into being, but I know OSHA and EPA came during that period of time.
So they start having these regulatory bodies that are, again, requiring answers. We'll say it that way. Is they're not necessarily, they don't prescribe a method. They don't necessarily tell you how you have to do your investigations.
They're gradually developing. Let's put it that way.
They're gradually developing and saying, we want answers in these incidences and we want to reduce them. You guys need to do that. And so that starts.
They're usually there because some big accident happened and government had to do something. So what did they do? They created a regulatory agency.
So we get the 70s are kind of starting some of these tools, and we get into what's next on your timeline.
Well, I've already really gone through my timeline. We're in the 70s. We get to the 80s, and that's where I get involved. I'm working at a major chemical manufacturer with a good reputation, and I'm working on human factors problems mainly, but I get involved in also incident investigation and how do you learn from incidents. And I guess I had a unique background because I came from the nuclear Navy. I'd been involved in a high performance organization, high reliability organization, if you want to talk about it that way. I'd From that experience, I understood equipment reliability pretty well, and I'd gone to the University of Illinois and studied under Dr. Charles O. Hopkins, human factors, and started off a program there with the nuclear engineering department to include human factors in a nuclear engineering degree. And so I had that unique background with my operational background from the Navy and a practical approach to things. So all those sort of came together that really eventually leads to the development of Taproot, which, for interest's sake, the word Taproot came from, we were going to develop software in, I think, 1990 or 1991. Probably late 1990 we started developing software. And back in those days, software development wasn't the same as it is now. And we were looking for a name, and I thought, well, we're going to have this database of root causes, and we're going to tap into that database of root causes. And all of a sudden, Taproot just came out as, oh, that's what we'll call it. We'll call it software Taproot. And pretty soon it became the name for the whole system, the Taproot system, or Taproot root cause analysis. And interestingly enough, probably by the mid-90s, I got a call from Ludwig Benner, and he was asking me, did I invent root cause analysis? And I'm like, no, it wasn't me. This goes a lot back further than me. I've made a system that's successful. And what Taproot was all about was getting people to be able to find human performance causes based on my human factors training, and also equipment causes, and also management system causes, to help people develop higher reliability organizations, more reliable human performance, and more reliable equipment performance by doing root cause analysis of, started off with, reactive problems. You learn by what goes wrong, and you learn not to have it go wrong again. So you stop having problems by fixing the ones you have. By the way, as compared to proactive, which you go out and imagine what could happen, in this case, you know this happened, you know it could happen again, and you're trying to prevent it from happening again with root cause analysis. Now, you can use root cause analysis the other way, and that is to use it proactively by going out and looking at either hypothetical or your projections of what could go wrong, and you project what those problems could be, and then you find the root causes of them, or you try to eliminate the root causes before they, you know what produces successful performance, because these root causes are things that cause unsuccessful performance. So if you can find ways to either get rid of these bad things or implement these good things, you'll prevent things from happening in the future. And that's sort of where our definition today of root cause analysis comes from. But I'm really jumping way ahead there, because that's all the way in, oh gosh, when did we come up with that? 2000, the year 2000 maybe?
Yeah.
And so we're still back in the early
80s.
Well, no, 90s.
Well,
and 90s really, Taproot went through its major development in the 90s, and we got users in the nuclear industry, users in the chemical industry, refining, oil, aviation, what else? Hospitals, some kinds of manufacturing.
so
Utilities, definitely big utilities, besides nuclear utilities, regular conventional utilities and transmission and distribution, all these different places. And we start getting feedback on what makes what we do usable and how we can improve it to make more usable, and what techniques people really need and what kind of training they need. And we start refining our how do we get people trained? There's some people who just need to be basic users, probably a 2-day course, and there's some people who really need to be really good facilitators, and they need to start out with the 5-day course. And we sort of start putting the boundaries around how do you get somebody developed into using good root cause analysis.
So I wanna pull us back because you're running through the 90s really quickly.
Well, the 90s they did run by really quickly.
So I want to pull us back a little bit because I think there's a lot of, and we could almost go back and say the history of human factors, but that's a different.
So we already started that in the 50s, and
yeah.
I'm not going to go through all that. And by the way,
that's a different podcast.
I went back to the University of Illinois, back to the nuclear engineering department, and gave them a presentation because I was a returning alumni,
Yep.
and found out that none of this stuff survived me. That during the 90s, they had big budget cuts at the University of Illinois, and the psychology department, which was mainly not human factors people, decided this practical human factor stuff, it needed to go away. The Aviation Institute, which is where a lot of this was applied, needed to go away. And all of my advisors and I guess I'd say the people who were running this stuff in the nuclear, they all went away. And so all of a sudden it just disappeared. And there is no program linking nuclear engineering to human factors at the University of Illinois anymore.
So I want to take it back to the 80s because there's something that you comment on, and it's one of I think my more referenced blog articles, I believe, which was the definition of a root cause.
Okay.
So in the 80s, you kind of started this process with building Taproot, and one of the first things was, what is a root cause?
Well, it wasn't building Taproot.
It was at the time. It wasn't building Taproot.
We were trying to figure out root cause analysis, and we recognized we couldn't even define what a root cause was. And so Dave Bush and I went out to interview people and find out what root causes were, and we came up with a definition. Gosh, the most basic cause that can reasonably be identified, that management has control fix, and then we added to that later on, and when fixed will prevent the problem from happening again. And that created all sorts of consternation, because people would then start arguing about, well, what is most basic cause? What is this management controlled fix thing? And how do you know that your corrective actions will keep it from happening again? And all those are really good questions. It can be really good arguments. And then all of a sudden you're back into philosophy again.
Yeah. So I state this as there really wasn't a definition in the late 80s for root cause analysis.
Oh no, I would say there were many definitions.
Yeah, there was no standard definition, and
I would say today there's no standard definition.
But at that time in the late 80s, we saw a lot of these paths of cause and effect and the statistical side of it evolving. And so in 86, I think of two methods that kind of came out at the same time, very similar stuff. You had Six Sigma coming out of Motorola,
Yep.
which was really about statistical process control.
Right.
And that...
And they really didn't have a good root cause.
They were all about defect identification and control.
They had, some people used fishbone diagrams and some people used 5 whys.
And that was one. You also had similarly in the Ford, because like I said, in 80s was automotives trying to figure out root cause analysis in a lot of ways. So Ford had its 8D problem solving method, which again, in its element, doesn't have a good definition of what root cause analysis is. So both of these methods were...
They use brainstorming as one of their tools. If you want to talk about a poor idea for root cause analysis, is just get people in a room.
So a lot of these methods were recognizing that they needed to understand the problem, but they didn't have a good process for developing it. So this is where you see Six Sigma, Lean, 5 whys really, I would say, blow up on the scene as a easy to do thing. Right? Everybody can ask why 5 times.
I don't really. I think there were people thinking about that, but I don't think they really blew up until in the 90s.
Well, that's what I'm saying. It starts in the 80s and it gets put into the business practice in the 90s. And so you can almost plot in the 90s, because I remember when I was getting training at the manufacturing group they walked through their history of all of these.
Right.
And this was when this was when Six Sigma was introduced, and this is when Lean was introduced, and this is the year that they were combined because they were.
So I can remember that.
Yeah.
I remember when they decided they were going to introduce Six Sigma someplace, and I was there, and they really didn't, but they started to.
Yep.
And then they decide, well, this is too hard. Let's do lean. And then they half implement that, and then say, well, let's combine them. We can do both at once. And I just, there was what do I call that? How many people today are doing Six Sigma or straight lean? There's still some lean ones out there.
Mm-hmm.
I don't think there's many straight Six Sigma ones anymore.
I think Six Sigma's been eaten by the lean groups.
Yeah. And even the lean stuff, there's some, 5 S's you see out there.
Well, there's a lot of the lean tools will always stay in there.
Yes, exactly. Rather than a whole lean program, there's some lean tools.
Yeah, and there's quality management systems have all basically incorporated the lean tools without. I would say they don't always prescribe the 5 whys. They'll take any root cause analysis method, but the I won't call them gurus, but the people that sell it definitely still teach 5 whys. And you can see there's a million and one people teaching 5 whys.
Well, heck, you could watch a YouTube video and know 5 whys.
You can get it from that. Your children will understand it. But you can see that progression. They recognize there's a need for quality control. There's a need for safety and performance improvement. There's a need for understanding the problem and fixing it. But what I think, and this is the difference between, I think in the 90s from, where you guys brought in the human factors versus all these other paths that are still trying to use that cause and effect method. And there's a lot of other cause and effect methods out there. All of those have the same, I would call it flaw, which is bias. And that flaw is experience and bias. So I call them bias-based methods at this point. You see those, they'll crop up with different names, but all of them are they don't tell you something you don't already know. It's you taking your knowledge and splitting it into whatever form it is. Maybe it's 6 M's. Maybe it's some different type of mapping or something like that. But they're taking your knowledge of processes and industry and breaking it into more granular and granular definition. And I think that it will always fail.
Okay, so let me go back and tell you my experience with this. All right. So first getting there when I worked at the highly reliable chemical company that I shall not name, was that I looked at their investigations, and they were not, any of them, finding the root causes, what I would call root causes of human performance problems. In fact, they tended to make things equipment problems, and when you talk to people off the record on the side, they'd say, well, listen, if we were to say there was a human error, somebody's going to get fired, or somebody's going to get blamed, or there's going to be blame, or there's going to be punishment. And so we don't want to find human errors. We try to make it equipment problems because you can't punish the equipment. And so they were like, they didn't know what they didn't know. They didn't know there were reasons why people were making human errors that could be fixed. They thought it was very blame oriented, all human errors were. And so we had to come up with a system that could get them to see causes for human performance problems, because I certainly didn't want to investigate every incident that there ever was, and had to be able to train people. And we got a little bit of a start at doing that before I started system improvements and went off to teach the world. So every place I went, when I saw their incidents, and I don't care whether they had Six Sigma, whether they were lean, whether it was cause and effect, whether they had no system at all, people just wrote reports and came up with things. They didn't, almost nobody had any experience in human factors. And I think that was because human factors was still in the early stages of development. For instance, Chuck Hopkins, the guy that I learned from, it was interesting. He was probably, I'd call him a second generation human factors person. Early 60s is when he started his professional, late 50s, early 60s, started his professional development. And he got, one of the jobs he got working for Hughes Aircraft was designing the Gemini capsule, human factors layout of the switches in the Gemini capsule. In the Mercury program, the astronauts decided they didn't just want to be monkeys going to space. First we sent monkeys to space. Monkeys didn't do anything to fly. They just went out and came back. Well, the first astronauts in the Mercury program said, all I am is a human replacement for the monkey. I don't have anything I can do, and I just go out, fly around the world, and come back and land, and you could have a monkey doing this. And so they said, if I'm going to fly a spaceship out to space and back, I want to have some control of this. And so then for the Gemini program, they human factored the human machine controls that were going to be in that capsule. And Chuck Hopkins was one of the guys who did that. So that's what makes him, I'd say, second generation. First generation into World War II, he's second generation. I'm probably fourth or fifth generation by the time I come along. So when I came along with Chuck Hopkins, and this is really getting back to root cause and the history of root cause, 3 Mile Island had happened, and he led a team that looked at the human factors causes of 3 Mile Island and what they ought to be doing in the future. And he had a big, thick report they'd written, and that was part of my first semester of my master's program, was to take a basic human factors course, read this big, thick report, and then sort of do a debrief with the guy who wrote it of what did I think and where did they need to change things and where did this go. So it was real interesting in the report. All the time you'd see this, and you ought to have a human factors expert do an evaluation of whatever it is. And so I said, Chuck, I see all these human factors expert people. What does it take to become a human factors expert? And he started laughing at me. He goes, nobody's ever asked me that question. And I said, well, I sort of would like to become one. What do I have to do to become one? And he goes, well, let's sit down, and what we'll do is we'll come up with your master's degree program, and we'll have you take the courses and do the practical things that you need to do to be a human factors expert. And I said, okay, sounds good to me. So at that time, there was no certification as a human factors professional. There was a society called the Human Factors Society, and people belonged to that and could become members, but what it took to be a human factors professional really wasn't developed. Yeah. And so I learned those things and did those things, and then probably 1986, 1987, around those years, they formed a society to certify people as human factors professionals, and I was the number 85th person that got certified. So it was one of those, okay, now we can say these people are the human factors experts, but nobody doing root cause analysis. Well, very few. People in the Human Factors Society that get hired for a particular job might do an investigation of a problem.
They might be one man on a team.
Well, they might get hired to do some kind of a study.
Yeah.
But there was nobody investigating incidents at big chemical companies, at refineries, at oil companies, at utilities that had a human factors background. They just didn't exist. And what I did, where I was working of developing a human performance improvement program, didn't exist. IMPO was I almost got hired at the Institute for Nuclear Power Operations because they were developing a human performance HPES, Human Performance Evaluation System, which was a root cause system for human performance. And I almost got involved in that, and I did get involved in its review, and I added several things to it that were missing from it. So that was all back in the mid 80s, early 90s kind of time frame, and from that, a lot of things sprung up, and from that, really, Taproot came out of it.
Yeah. So I kind of think of this as another one of those, pivotal moments in root cause analysis would be the inclusion of human factors in root cause analysis.
I would call them accidental pivotal points.
Yes.
It wasn't like anybody said, we need to get some human factors
Yes.
involved in this, except for me, and so that nobody was. It just became. It was an accident.
Yep. And so, when we look at, basically you're like Socrates, right? Eventually,
I'm not going to be Socrates. Socrates had to take hemlock and kill himself, so I'm not doing that.
So I think post 90s, and most of the things that we've mentioned now that were late 80s into the 90s still exist in some capacity today in industry, right? You'll find Six Sigma's kind of dead, but there's
still people doing statistical process control.
Exactly. So all of these things still exist out in there. Lean's still out there. But I think of it as you have people discovered
5Y's still out
still,
there.
5
As
Ys
bizarre as that sounds.
Fishbone diagram's still out there. And it's really at this stage, these methods don't necessarily go away, but people discover the value of human factors. And that's really, I think, the difference in now 30 years later than the 90s. It isn't that there's been a huge shift or change since then. I really don't think there's really been any big changes since the 90s in our understanding of root cause analysis. And maybe you correct me on this.
Oh, our new definition came out after the 90s. That was 2000.
I would say that would be something there. But I think as far as understanding of the need for human factors, I think
okay, I agree, but there's still people who don't really understand human factors, who are teaching human factors,
yes,
and B, saying you can learn human factors from us, and they don't have a clue what they're teaching. So,
yes. So I think the industry has recognized its need for this, but I'll agree with you. There's a lot of snake oil salesmen that grabbed a term and they're using it without the background and the history. But I think we can end kind of the history part there with the current definition we use for root cause, because I think it sums up that whole history of understanding all the way back from cause and effect. What is root cause analysis and how did we get to where we're at? So kind of walk us through that new definition.
Do you have the definition written down? Because I don't.
Okay, so I have it.
Okay, go for it.
So a root cause is a missing best practice or piece of knowledge that would have prevented the problem or significantly reduced its likelihood or consequence.
Okay.
So
that's a definition of a root cause.
Yes, and I do see other people use it, so that's how I know it's getting. It's getting out there.
People are still with the old definition that I mentioned before.
I've seen that too.
More than they are with the new definition. But I think the importance of the new definition is it takes root cause analysis from a negative, which is we're looking for what went wrong and almost who to blame, to a positive, we're looking for ways that we can prevent these things from happening occur in the future by applying knowledge and best practices. And what if we have a problem, it's because we aren't applying the right knowledge and we haven't adopted the right best practices. It isn't because somebody's a bad person.
Yep. And I think that's the biggest shift, is the idea that root cause analysis is not about looking at who to blame. It's not about looking at the mistakes that someone made.
Well, it is.
It's not. But it's about.
If there wasn't a mistake, we wouldn't have had an incident, probably.
Fair
right?
enough.
Well,
maybe.
Maybe.
But it's about looking what in our system is allowing those mistakes, those equipment failures, those breakdowns, and what we can put in place to prevent that. It's a forward
and the
looking.
strongest things we can put in place rather than the weakest things we can put in place.
And it's not singular, because there are multiple best practices we can put in place. There's multiple ways that we can strengthen a system. It's rarely just one person screwed up, one person's to blame. There can be lots of little things in our system that we can do to improve our chances of being safe, to improve our quality, to make sure that we're getting the right stuff to the right people. So I think if you look through that history, going from there's a cause and effect assumption to there's a person to blame, that's sort of kind of in that early safety side of it, they screwed up, to this idea of we need to have a
human error too.
Yeah, human error. We need to have a process for understanding the context behind what happened and look at the good human performance best practices we can put in place to prevent those things we did not want to happen.
To improve performance.
To improve performance. And so I think that evolution is a fascinating one to see. And I say there haven't been changes. I know we've done a lot to change and improve at least our understanding of both snap charts, causal factors, tweaks we've made to the trees over the years. And I think we'll continue to stay on the front of those things and looking about how do we improve human performance and improve equipment performance. Probably should have said Equifactor. We'll have to bring Justin in for the history of Equifactor.
That's a whole different story. Well, in our history, it starts in about 1997. Equifactor does, and becomes a technique that's in the book by the year 2000.
Yep. So
it really is. What are we? It's at the turn of the century, 2000.
Yep.
That's the turn of the century,
Yep.
Isn't it? We go from the 20th to the 21st.
So, if anybody listening wants to learn more about Taproot, about root cause analysis, what's their best resource?
Well, besides obviously this video, the best resources go in one of our courses, I would say. Like I said, I think I said this earlier. If you just want to understand the basics, a 2-day course will get you started. If you want to become good at doing this and become a good facilitator, you probably need to go to a 5-day course. I'm mentioning Equifactor. If you want to learn to do this for equipment stuff, you can either take the 2-day Equifactor course, or the 5-day course has a section about Equifactor and a lot of other things in it. So training is an obvious answer. We've got lots of books.
And I think
people do read books still, I think, and they could do that, but the course is a lot faster than reading a book.
So they can find out about those courses. They can also find out about our conference, the Taproot Summit. They can find all that on our website. Links below. You can go check out and see which things are.
www.taproot.com.
Yep.
It's a pretty simple place to find.
Yep. So you can follow those to get more information, get more knowledge, and improve your company's human performance.
With that, is there anything else we need to discuss, or have we?
I think we've got it.
History sort of ends then in 2024 with us still working to improve Taproot, and every year we make adjustments, I guess I'd call it, and make things better yet. So it's not like we've stopped learning and stopped advancing. There'll be wait another 10, 15, 20 years, and there'll be
it'll be better yet.
New stuff to talk about. Okay, thanks. Bye, everybody.